Hello, everyone, and thank you for joining me on my series called Build with Near. My name is Gyan Lakshmi, also known as Gyan, and I'm one of the ambassadors with Near India Guild. I'm really excited to build these tutorials for you. I recently finished my Near Certified Developer program, and I highly recommend that program for those who are interested to learn to develop on Near. And inspired by that program, I thought I would do my own series for folks who are looking to develop on here, just to teach them how to get started with smart contracts, how to write your own smart contract, and a couple of unit tests if possible, right? So this video is actually a continuation of my part 2 video, where we already started writing our own smart contract and wrote most part of it. But today what we are going to do is we are going to run the smart contract and call the functionalities of the smart contract and see how that works. So we have finished the setup and read contract. We are now writing our own smart contract and trying to run this, right? So the language that we have opted for is assembly script. You can write near smart contracts in either Rust or assembly script. We have chosen to go ahead with assembly script because it is fairly easier. Also, I'm more confident with assembly script at this point in time. The contract that we have written models one of the betting features, that is bet even or odd at a roulette table when you go to a casino. So the roulette table would look something like this. You can bet your money on whether the ball will land on an even number or an odd number. Of course, you can also bet on other features, but what we have built the small contract is on this, right? These are just a description of the contract. So as we have already written the contract, let's move to the contract itself, right? So I'm going to share my contract, my entire screen. So here is the contract that we wrote last time. Just to quickly walk through the contract, we have a class called roulette, which is the game itself. We can create multiple games. When we create the game, the workflow would be something like this. We create a game and put in some initial amount of money, which is called initial amount, which can be retrieved from the context dot attach deposit when the particular game is initialized using the constructor, right? And when we create the game, we call the constructor. There's a function called create game. It creates an ID for this particular game. The player who's joined, nobody has joined yet, so it's just a none. The bet amount by the player is 0. So far, there hasn't been any betting. The guess is also by default false. And the initial amount that we are setting is the amount that we send while deploying the contract. The game state is an enum, which will have created, joined, or ended. So initially, the game state is created. We have a winner, which is by default the person who creates the contract. Now, the create game will just create the contract and set all the things. We have a persistent map, which will store the game ID, which will store a pair of the game ID and the game itself, right? So to refer to the game. Now here, when somebody wants to join the game, they need to send some kind of attached deposit, right? Some deposit with this. And they will be the context dot sender, that is the person who's sending uh, who's calling this function. Then they will send a guess, which will be a boolean, either true or false. So we decide to go with true as 0, and that is even, and 1 as odd, right? So false is odd. Now here we also need to set the state of the game, right? That is dot joined, right? Now there is another function called end game, where we can end a particular game. What happens at end game is there is a random number that is generated again between 1 and 36, because the numbers on the roulette wheel are 36, between 1 and 36. Actually 0 to 36, but we'll go with 1 and 36. And if the winning number is odd, right? And if the user has also guessed as false, then the user is the winner, the one who plays the game. If the winning number is even and the user has guessed true, then again they are the winner. In the other case, the winner remains the creator of the contract, that is the casino, for example, right? Here we are going to update the game itself, the game details every time at the end of this one. We would also want to update the state of the game, right? We haven't used the state anywhere yet, but maybe I'll show you where we can use it. Maybe you could improvise this contract, right? Now here, the last bit that we have done is we want to transfer all the winning money to the winner, right? So if the player gets it correct, they win. Otherwise, the contract itself or whoever deployed the contract wins, right? So here we use a contract promise batch, which we have taken from the near SDK itself. This is another contract which will help us wrap the winner in such a way that they can become the beneficiary to transfer the amount. Here we are adding both the bet amount by the user and the initial amount to uh, add them to transfer it. So here, as we said, that some initial bet amount should be there. So let us have a condition here, right? That the context dot attached deposit should not be equal to 0, or rather we say greater than 0. We just return false. We can have a return value which is Boolean, right? At the end of the game, we can return. Yeah. All right. Sorry, if it is it is 0, right? So if it is 0, it will return false. So it has to be greater than 0, right? Any finite number. Now let us go to, right? Now what we want to do is we want to deploy this contract. So if you go to the scripts folder, you will see two scripts, one.init.sh, where the contract is actually being deployed. And you will see another script called 2.run.sh, where the different functions of the contract are being called, right? So what we are going to do is first we are going to run the first script, that is 1.init.sh. Since our folder name, we have kept it as sample, we'll just continue with the same, right? We'll set an owner for the contract as my address, who will be actually deploying once this particular contract is deployed, right? So let us go to our terminal. So we are here, right? Can make it a little bigger. We go inside scripts and run this. So there is no contract environment variable. There is no owner environment variable that exists as of now. So what this script will do, if you see here, right, it will delete the near dev folder if anything was there earlier, right? And it will build the contract for us. And then it will deploy the contract, right, on a temporarily created account. So you can see that it is building now. So it will take a couple of minutes to build the contract. Now that we are setting up, or rather we have set up the contract for deployment, we have completed the first chapter and we'll be moving on to actually seeing how to deploy our contract. Thank you everyone for joining me in this session. Looking forward to seeing you in the next chapters.